Good afternoon, everybody, and thanks for coming to this Ambari talk. I know this is the last session of the Hadoop Summit, and everybody might be a little tired, but I hope we can make it worthwhile. So let me briefly introduce myself. My name is Yusaku Sako, and I work at Homeworks, where I lead the development team for Apache Ambari, and I'm also the PMC chair for the Apache Ambari project. And my co-presenter here with me today is Sumit Mohanty. You want to introduce yourself?
Okay, so I also work in the Ambari team, and I also work in the Slider team as well. I mostly focus on the back end and the Ambari agent and performance areas of Ambari. Thanks.
Cool. And I mostly focus on the front end aspect of Ambari. So we're going to talk about what's coming up in Ambari, and also features that are already in, but sort of new, and not everybody might know about them. So we're going to cover a lot of things today. So just can I get a show of hands on who in here are responsible for managing Hadoop clusters? Awesome. And who is using Ambari? Wow, a lot of people. That's cool. All right, so I think most people know in this room know what Apache Ambari is, but for those of you who don't know, Apache Ambari is 100% open source platform for making Hadoop cluster management and use simpler. Our mission is to make Hadoop operators and also users' lives really simple. And also, Ambari is not just a management software. It is also a highly extensible platform, and that's what makes it really powerful because people can basically come up with their own use cases and own extensions to Ambari and make Ambari better. So before we go into new features, let me briefly summarize what's been happening in the open source world for Apache Ambari. So this is where it all started. This is the very first JIRA that resulted in Owen O'Malley committing initial Ambari code. This was back in September 2011. So that was not quite 4 years, but around 4 years ago. And fast forward to today, June 2015. We're up to 11,000 range in JIRAs. That's a lot of issues that were resolved and also new features added. And we currently have 100 plus contributors. That's not an exact count. I think it's a lot more than that. But and we right now have 50 committers. And most of these committers are very active and writing code, reviewing code, and committing code on a daily basis. So far, we have about 12,000 JIRAs filed overall, and out of which 11,000 are resolved. So I did a quick calculation. This is just a very rough estimate. But let's say that 1.5 days are spent on each JIRA. Then basically, in aggregate, it's people spent 66 person years on this project. And I think this is a very conservative estimate, and I think there's a lot more person years that went into this project so far. And also, Ambari today is used by hundreds of companies. And this slide is showing how big the Apache Ambari project is in the Apache world. So did a little stats. Basically, this is JIRA count by project basis. And Ambari is number 4. Just the other day, I said it's number 3, but it turns out Hadoop is sort of broken up into several projects. And if you combine them all, Hadoop comes in at number 2, just behind Apache Flex. HBase is 3rd, and Ambari is 4th. So what I'm trying to show here is that Apache Ambari is a significant project with a lot of contributors, a lot of interesting things happening, with a lot of users. So here's a timeline showing the activity for the past 1 year or so. So basically in the past year, we resolved about 7,000 plus JIRAs with a number of releases, and each release containing a lot of new features and bug fixes to address problems that have been encountered in the field. And the focus of today's talk is going to be Ambari 2.0, which came out in April. And also there's a maintenance release that went out, 2.01, that was back in May. And also Ambari 2.1, which is coming up very soon. We just created a branch 2.1, and we're stabilizing to prep for the release. So we're talking weeks, not months. Okay, so I'm going to hand over to Sumit, who's going to start talking about some of the new features.
Thank you. So I'm going to cover rolling upgrade alerts and metrics, and then after that, Isaku is going to cover essentially a lot of enhancements that was done on the front end. So let me start with rolling upgrade. So the goal, pretty much based on the name, is very clear. So as you can know, generally any Hadoop cluster is fairly complex. I mean, you start with the basic Hadoop pieces, HDFS, Yarn, and HBase, but then you can have anywhere from 5 to 15 other different services that are sitting on top of these core services in some form or other. So obviously, releases happen, I think, as frequently as once every 6 months or so. So naturally, upgrade is a very common problem that most of the IT admins encounter. So the rolling upgrade is essentially to tackle two different problems related to upgrade. So one is the upgrade, which itself can be fairly complex and time consuming. And the second is not having any downtime. So you go through a rolling upgrade, and essentially the users will not notice that there is any downtime, and everything should run smoothly, albeit depending on the stage of upgrade may be a little slow, but in general there is no downtime. So rolling upgrade is one of the biggest feature that I think Ambari has implemented over the course of last several months, starting from 2.0 and also going all the way into 2.1. So the general principle is fairly straightforward. So the idea is you should be able to deploy, you should be able to install multiple versions of Hadoop at the same time. Now, installation by itself doesn't necessarily make any changes, but a lot of work went in to ensure that this is possible. So as you can see on the left-hand side, essentially an example of 3 different versions of Hadoop that is actually installed on the same machine. So the idea is that at any given point, you actually have one version of Hadoop that is installed and current and potentially active. Then you have a future version of Hadoop that is installed, and then at some point you are going to orchestrate a rolling upgrade. Now, along with the binaries, naturally the second particular aspect for any deployment is the configuration, because it is not necessarily guaranteed the same configuration is going to work across multiple versions. Typically they do, but in case you don't, you may have a situation where, let's say, your node manager is of one version and your data node might be on another version, or there is a difference between a master and a slave. So naturally there is a requirement to have 2 different configuration folders to basically capture the configuration for various versions. So this is basically the bare minimum and the bare metal view of when you try to look at rolling upgrade from disk upwards. So when you come into Ambari, this is sort of a summarized view of what's happening. So if you are actually performing a rolling upgrade, you are at that stage where, in this particular example, HTTP 23002253 is the build number, which is the current, and then there is some version in play with respect to you are planning to upgrade or you are actually in the process of upgrading. Now, there are a couple of big advantages that come in here. So one is, it is very easy for you to move on to maintenance releases, because essentially rolling upgrade will allow you to move from a major release to another minor release, which is basically a maintenance release, or you can move from, let's say, HTTP 2.2 to 2.3, which is a much bigger migration corresponding to, let's say, upgrading most of the components of your stack. So the way rolling upgrade is designed is that the idea is to be be as safe as possible. So it is not, the goal is not necessarily just do a one click and you come back after an hour or so and upgrade is done, because the goal is to make sure that the work doesn't get affected and you don't go through any data loss, etc. So what Ambari, especially the design standpoint, what it has done is there is an orchestration layer where we essentially code up what upgrade means, because upgrade can mean anywhere from just update the binary to maybe do some config transformation. So the idea is not necessarily a one-click upgrade, but actually provide a guided flow or guided orchestration that you can go through step by step to finish your upgrade. So you have a choice of running service check at any given point you want, or you can choose to ignore if there is some minor failure because you actually know that that particular host or that particular data node is actually okay. Maybe there is something wrong on that machine and you can ignore that. So there is some flexibility, but the idea is that once you start a rolling upgrade, it will essentially push you through various stages, trying to upgrade HDFS first, then YARN, and then as you go up the stack, various other service components. So it basically dynamically produces a full orchestration of rolling upgrade based on the exact deployment that you have for your cluster. So that's really what it is. So it's not a one solution that fits all. It looks into your deployed cluster and then figures out what are the steps that is needed to finish up rolling upgrade. So I'll just quickly go through certain aspects of rolling upgrade. For example, I did mention that rolling upgrade is actually a catalog, because obviously if I'm upgrading today from HTTP 2.2 to 2.3, I really don't know what will happen if I upgrade from HTTP, let's say 2.5 to 2.8, because the combination and the services that you need change. So what Ambari team essentially did was created a declarative, essentially an XML file that allows us to design the steps of upgrade. So this is one example of where we want to run the service check of HDFS, MapReduce, YARN, and HBase, but we don't necessarily need to run the service check for Ambari metrics. It's just that this particular combination made sense for the upgrade. I believe this is from 2.2 to 2.3. And similarly, there are plugin points where you can run custom scripts. Your custom scripts can be anything. Maybe you want to perform an operation that is specifically required for name node or specifically required for some other service. So I mean, it is actually possible. Anybody using Ambari can plug this in also, but it also makes the life of the developers easier as we add support for upgrade of various services and various versions. And just to continue, you can, like I said, you can look at the failures. It can be as interactive as you want, in the sense if there is a failure, you can choose to go and actually fix the failure and retry the upgrade, or you can choose to ignore and then say that let's proceed forward. And this is another example of how we capture the fact that a configuration may have to change between one version to another. And finally, of course, downgrade. So no rolling upgrade is technically complete till you actually have a equivalent support to downgrade. But like I explained initially, because the fundamental idea is you have a side-by-side installation, so technically upgrade and downgrade are a very similar process. You just go through flipping the symlink from one place to another. So that's pretty much a very simple summary of rolling upgrade support, and we have actually used it in many live clusters, and it certainly does a very good job of capturing your cluster specific deployment and then how to translate it to a very friendly orchestration that you can just navigate step by step. Another topic that I wanted to cover today is alerts. So Ambari Alerts is today essentially an in-house developed alerting system, which at a very high level is summarized to the alerts into sort of 5 categories. Obviously, you have your standard port. You just watch a port whether it's actually active, or you can watch a HTTP endpoint, and maybe you can actually look at a metrics that is being produced by your service. But in top of that, you can also aggregate. So you can get data from various these sources, and then you aggregate to build an alert, which typically will appear as percentage. Maybe 10% of my data nodes are down, or 10% of my region servers are down. So you can actually combine the metrics and you can build a more comprehensive view that essentially appeals to what your specific need is going to be. And finally, as an extensible point, because like Yusaku pointed out, one of the core goal for any Ambari feature item is to make sure it is extensible. It helps us, the developers, but it certainly also helps anybody who is using Ambari. So you can always drop in a custom script, and that Ambari will blindly execute, and based on the return value can produce an OK or a critical alert. So this is essentially some screenshots of alerts that are available by default in Ambari. So when you deploy Ambari, you obviously get a bunch of alerts that are configurable, but you can certainly enable them, disable them, and I think in the demo we probably have some sample of where you can configure the alerts. But if not, any deployment of Ambari, you can actually pick an alert, you can configure the various thresholds that are essentially applicable to your own scenario. And this is also another example of where alerts are actually visible as well as they are stored in the database. So you can go back to the database and then query for a historical perspective of the alerts in terms of figuring out how many times this particular instance may have gone to critical and then come back offline. We just store the differential, so it's not like we are completely bombarding the database with alerts every minute. And then this is another example of how you can customize the alerts. And it's pretty powerful. So once you look at the default one, and if something doesn't make much sense for your specific instance, you can just go ahead, edit it, and then you can have an alert that is applicable to the specific scenarios. So the final one that I wanted to cover was metrics. So metrics, like the alerts, was another in-house project. So these are some of the goals that basically drove us to develop the new metrics. So the idea is, at any given point, you have a lot of services producing a lot of metrics. So obviously, the primary goal of metrics is to collect from all the services that you have, HDFS, YARN, etc. And then once you collect the metrics, you always collect them at a precision that makes more sense as you're looking at last 1 hour or last, let's say, a few hours. But you, of course, always have a choice based on how long you want to store your metrics. And therefore, if you have a high precision, then obviously you're producing a whole lot of data. But you can reduce the precision. In that case, you can actually store a much longer history. So depending on your requirement. So that was another requirement where you can actually tune the precision at which you want to collect the metrics. So naturally, every time there is a collection, there is a requirement to purge, because obviously you do not want your database to continue grow with the metrics. So if you look at the metrics, you can see the collection as a part, but actually managing the life cycle for what you have collected is also a very integral part of the metric system. So this Ambari metric system is basically designed to tune in terms of collection and retention, as well as if you want to siphon off to a long-term storage if you want, whether it is OpenTSDB or any other storage that actually makes sense, you can just move metrics out of the core Ambari database, which is basically HBase. So at a high level, the way a metric system works is, again, very similar to any other system you may have, which is on the left-hand side, you have the sources, which is the host or the individual daemons and services. And that goes into a metrics collector, which is sitting on top of HBase. Now, it can be configured to run against an embedded HBase, which means that you can certainly just dedicate one host and the metrics will be stored on a disk. Or you can configure it to run against HBase that is specifically created to store metrics. So maybe it's a multi-node HBase with as much storage as you want. So it is pretty easy, just a matter of configuring the AMS to either use the embedded HBase or the HBase that is distributed and outside the system. So it's your choice. And once the metrics is stored, you naturally get all the goodness of HBase that is already available. So for example, you can use Phoenix to query, and you can even directly go to HBase to query, but then again, you need to know the data structure or the structure of the metrics that is stored. But in any case, there is a REST API that is available. And the REST API is completely make sure that you can make very human readable queries, and then the result obviously is very human readable. So essentially the REST endpoint is the preferred endpoint to go because that's what Ambari UI also uses. So this is just to impress on a fact that when we designed the system, we ran some tests against the embedded mode. For AMS, this is the case where HBase is embedded and it's actually a single machine on a single disk. So this is roughly is the level of performance that we could guarantee. So based on our experience, you can almost be assured that up to a 300 node cluster, the AMS can actually handle it on a local disk on a single machine, but perhaps maybe about 16 gig or 32 gig of RAM, I don't remember. But other than that, it can definitely handle up to a 300 node cluster. So just to summarize, it's using embedded HBase. It is actually leveraging a lot of Phoenix support to make sure the query is efficient and there is ample hints. So it is a fairly performance optimized system for the nature of metrics that gets collected, which is metrics as well as aggregation across cluster, across host, across clients, etc. But it's a highly optimized system for this purpose. Anyway, at this point, I will hand over to Isaku.
All right. Thanks, Sumit. All right, so now I'm going to talk about some brand new features that are going to be available in Ambari 2.1. These features are already available in Trunk, but if you want to consume it, please wait till Ambari 2.1 comes out in a couple of weeks. So one of the key features that we added is customizable service dashboards. So we've been hearing from Hadoop operators that the predefined graphs that are shown in various service pages of Ambari, they're good, but I want to see some other metrics because I'm interested in performance in this criteria and that criteria. So basically, we added the ability for users to create new widgets from the GUI itself. And there are several different widget types that we made available. One is time series graphs. Another one is dial gauge, which shows percentage, and based on the threshold, it shows orange for warning and red for alert, critical and things like that. There's also a number widget. Basically, it just shows the number that's pulled from a specific metric or a combination of metrics based on some mathematical formula. And also a template widget where you can basically embed text and combine with a number of metrics. And also the ability to customize the layout and persist it. Meaning, you can hide certain widgets from appearing if you don't want to see it there, or you can drag it, drop it, and the customizations are remembered for every individual user. And I think in the past, if you're just a read-only user, these customizations were not saved. So now layout customizations available for everybody. And also, the ability to share widgets that you've created with other users on the system. So, you might create a widget and play around with it, and if you find it useful, then, you can make it available so that other people can drop those widgets onto their dashboards. Right now, in the upcoming Ambari 2.1, layouts themselves are not shareable. So this is one feature where, one person in the organization maybe sets up the HBase service dashboard in a certain way. And this is the way that you want to check out HBase, and share it with all the others in the organization. But that feature is not available yet. But it's something that we plan to add in the future very shortly. So here's a recorded demo of this customizable dashboard feature. So here, the user logged in and is looking at the HBase dashboard. And it's going through a sequence of adding a new widget. Just kind of going a little faster than I anticipated. But basically, the user is trying to create a new graph widget. In this case, load averages on the name node host itself. So the user can select, I want to show the load averages on the active name node. The user selected this 1 minute load average metric. And as you can see, it does a live preview of the graph, and you can keep adding, data series. So, in this scenario, we're adding, 2 lines to the graph. One is 1 minute load average, and another is 5 minute load average. And as you can see, there's this expression builder, and in the example, it's just doing a straight up drop-in of the metric selected, but you can form mathematical expressions if you want to sum, various metrics together, or if you want to divide or multiply by 100, things like that you can do. You can't do, log and max, min, things like that, but those are something that, we can easily add in the future. So we just added this name node load average widget, made it available, drag it into place. So that was how you add a new widget onto a service dashboard. And as I mentioned earlier, our goal is to make everything extensible and pluggable. So if you're creating a new service for Ambari to manage, then if you want to define widgets that go with the new service by default, it's very easy to do. You just drop in a JSON file for the widget definition for that service, and you just restart Ambari server, it gets loaded up, and all these graphs start showing up. And to make these widgets available, you don't have to mess with any of the front-end code. So it's as easy as just dropping in metadata. Another major feature that we added in Ambari 2.1 is called smart configurations. So as you all might know, Hadoop and its ecosystem components, they're very, very difficult to configure because just the sheer number of parameters that you can tune, and also these parameters, values can optimal values can be different depending on your physical hardware or combination of daemons that you're running on each service, which features you have enabled, things like that. And and also it's hard to know which ones should I be tuning. Out of these 200 parameters, which ones should I go through, or are there a specific set that I could should really focus on to get the most out of my tuning. So Ambari helps you with that with smart configurations. So what you see here is a smart configuration version of Hive, and as you may know, Hive has 400 odd configuration parameters, and a lot of the parameters, you might, valid values, you set it to a certain exact class path, or comma delimited list of class path, and things like that, and it's very difficult to understand all the interdependencies when you have certain features turned on and combinations of features. So what we did here is, for example, in this case, we're turning on ACID transactions. I don't know how many of you know how to turn on ACID transactions in Hive. I certainly don't. And basically, this is showing you if you turn on ACID transactions, these are all the parameter changes that you need to make. And Ambari just figures that out for you and applies all these settings. Here's another example of choosing the authorization method as Ranger. And here are all the parameters that you need to change. So all these things, these are just internal details that users should not have to know, and should not have to care. And Ambari does all the work for you. And similarly for HBase, we have this smart configuration. And as you can see, there's some memory settings that you should be tuning. Here's an example of pull down that shows you valid values. But with Ambari, we want to be opinionated, but we don't want to restrict the user from setting configuration values to whatever they want. So for each widget, you can, this is what's called an escape hatch mode. And you know, when you click on that icon, it'll let you set the parameter to an exact value. Like for example, you know, you can set the major compaction threshold in milliseconds. But you know, typically, whatever is available in the smart config mode is, you know, what you should be dealing with. And you don't want to have to go to the escape hatch mode, but if you have to, then it's there for you. And also, you know, the sort of the old school way of exposing configurations, they're still available in the advanced section in case you need to tweak some parameters. And what's not shown in the demo is, let's say, you know, you turn on a feature and it has, you know, a lot of interdependent, you know, parameters that it sets behind the scenes. And let's say that, you know, you go to the advanced mode and you change something, or, you know, you change the list of class names or whatever, and it kind of invalidates the, you know, feature that you intended to set. Then, you know, Ambari would tell you, hey, you know, you have this feature enabled, but you didn't set it. This is sort of out of whack, and, you know, you need to fix it. So Ambari does that for you. So this is sort of the internals. And as I said, this is also extensible and pluggable. So, you know, if you want to add this smart config type of UI into the service that you're adding, you can just drop in and several XML files to specify how, you know, you want the layout to look like. For example, in Hive, we're using this is HBase. We're using like a 3-column layout. In other services, we're doing 2-column layout, things like that. It's all controlled through metadata in the stack definition and not UI code at all. And there are, you know, UI controls that are available, like the sliders that you saw, and also combo boxes, there's toggles for binary options, spinners for time range control, and list of enumerations. And you know, these controls are something that we built in. Might add other controls in the future based on what people need. And the smart configs right now is already implemented for HDFS, Yarn, MapReduce, Hive, and HBase. And you know, we plan to make other services smart configuration in the smart configuration format as well. Oops. Okay. So these are sort of the nitty-gritty details of how the metadata looks like. I'm not going to really go into this level of detail in this presentation, but just put it there in case you want to look back at the slides. Also, you know, as I talked, you know, a lot of configuration parameters have interdependencies. So if you change this, and this has to change, and there's a, you know, cascading effect of all the properties that that need to be changed, which Ambari manages, and this is how you specify the metadata for it. And next, I want to talk about Ambari Views. So Ambari Views is not a brand new feature. This was added back in Ambari 1.7.0. But so what it is, you know, it provides various applications from Ambari Web UI for basically not just for cluster operators per se, but even for, you know, Hadoop users, data analysts who do queries on Hive and Pig and things like that. So, you know, the intent here is that, you know, everything you touch on Hadoop, you should be able to do it through Ambari Web UI. And views, these are easy to develop. It's kind of like just building a standard web application or, you know, single page app if that's what you want to do. It doesn't have to be single page app. You could just, you know, build a sort of a standard servlet type, you know, web application. So there's no real need to understand any Ambari internals. And also it's very easy to deploy. So when you create a view, it creates a single jar file that you can just drop onto a folder on Ambari server, and it just auto expands and, you know, makes it available. And also, Ambari Views framework has this feature called auto-create and auto-configure. These are new features actually in 2.1. So basically, when you have certain services selected, like let's say, you have TES on your cluster and you install the cluster, it automatically makes the, TES view available on the cluster, whereas before, you have to manually create an instance using the Ambari GUI, but that was all manual. And also wiring up all the configuration properties, like, where's the location of the ATS and things like that. So if you have a cluster that you install through Ambari, then Ambari knows all that information, so you don't have to do all the wiring up. So here's an example of a view for cluster operators. So this is a Yarn capacity scheduler queue manager. And as you may know, if you've modified capacity scheduler configurations, it's very complex. And there's an inherent hierarchical structure, and all the queue capacity they must add up to a certain number and things like that. And it's very tedious. It's very easy to mess up. So this sort of GUI, so the capacity scheduler queue manager view makes that job very simple. And also, it has an ability to just push the configurations and make that effective. Here's an example application for just general users. It's HFS file browser. So it's just a GUI where you can just sort of navigate the HFS file system tree. You can rename files. You can upload files, download, delete, move, and so on. And Ambari Views can be used for application developers as well. And shown here are on the left is a view for troubleshooting and improving Hive queries, and on the right is for troubleshooting TES jobs. Because as TES jobs execute, they create sort of this DAG, and you want to know why your jobs might be running slow. And it gives you sort of a graphical view, and you can drill down to various logs and things like that. So it's very useful for troubleshooting. And also, for data analysts, we have created query editors for Hive and Pig, and also in the Hive query editor, it has an embedded troubleshooting tool, so that when you execute a Hive query on TES, again, it creates a DAG, and inside the Hive view itself, you can sort of troubleshoot TES jobs. So these are just example views, and possibilities are endless. And as I said, it's very easy to develop. So if you have ideas about what views could be useful to you and other people, please contribute. One thing that I want to touch upon was this notion of views-only mode. So what this means is that you can use your Ambari server and not necessarily have to install and manage a cluster in order to utilize these views. So you can essentially install Ambari server and point to other clusters that you may already have. So for example, if you want to use the file browser, or if you want to diagnose TES jobs and you didn't install these clusters using Ambari, you can still do that. Okay, and Kerberos Automation is something that we added in Ambari 2.0. And so previously, we had a wizard-driven GUI to enable Kerberos, but the job of creating Kerberos principles and key tabs and distributing them, that was up to the user. And now in Ambari 2.0, it manages everything for you. So all you need to do is create the admin principal and give the credential information to Ambari server. And when you enter the password, it's kept in the session, but it's not really persisted, so it's secure. And once the cluster is Kerberized, when you add hosts to the cluster, add components to existing hosts, add new services, principal generation, key tab generation, distribution, all taken care of for you. And it works with existing MIT KDC or Active Directory that you may already have. So one last thing that I wanted to talk about was blueprints. And it's very useful for automated cluster deployment and headless cluster deployment. And basically with Blueprint, all you have to do is make 2 REST calls. to provision a cluster. And a lot of people are using this. I don't know if you've heard the keynote on CloudBreak, or CloudBreak is a tool for quickly spinning up clusters, Hadoop clusters on-prem or on cloud. Blueprint is the key enabling technology for CloudBreak. Also, if you've been to Azure portal and if you've launched HTTP cluster creation wizard there, the backend is driven by Ambari Blueprint. And also in Hortonworks, QA department makes heavy use of Ambari blueprints to spin up clusters for running system tests and things like that. Blueprint, it can be used to set up cluster from scratch. But if you already have a cluster and if you want to sort of replicate it, it's very easy to do so. You just do an export of a blueprint using a REST call, and then you can just use that blueprint generated to basically start up a cluster installation. So here's an example of how you would create a 100-node cluster. And you just make 2 post calls, and that's all you need to do. And once you make the second call, there's a handle that's returned to you from the REST response, and you just need to sort of pull on that to check on the progress. So what's new in Blueprint? Blueprint has been around for a while, but what's new in Ambari 2.0 is that it supports various HA configurations. So if you want to set up name node HA from the get-go when you install the cluster, you can do that. Also RMHA, region server HA, so on and so forth. And also there's a new API call that was added to add hosts, Blueprint style. Rather than making a bunch of granular API calls to add new hosts to the cluster. And this is really new, exciting stuff in Ambari 2.1 is called Advanced Cluster Creation. And if you want to read up on it, please look at this Jira Ambari 10750. Essentially, previously, if you wanted to use a Blueprint API, you needed to bring up all the hosts, and and then after all the hosts are up, then you can make Blueprint call to install the cluster. But this actually requirement is very limiting in cloud environments, because you might be making a call to instantiate like 200 nodes, and if all the 200 nodes didn't come up, let's say 5 didn't come up. This happens very frequently, right? You don't want to be waiting and basically throwing away the cluster just because 5 nodes didn't come up. So basically it allows sort of on-the-fly registration of hosts and scheduled install tasks in a sort of a lazy manner. So that's all I had. One thing, so if you're using blueprints, there's certain things that you need to be aware of. So even as of 2.1, Stack Advisor, which does most of the smart dynamic config recommendations and validation, is not really integrated into blueprints yet. And also, you can't create a coverage cluster from the get-go. But those are basically 2 major limitations that you should be aware of. Okay, so that's all we had for today. So thanks for coming to the talk. And if you have any questions, we can answer them.
Thank you.